One single chip costs $40,000. The most powerful nation on Earth banned its export. And a black market now smuggles them inside frozen lobsters. Welcome to the most consequential conflict of our era. A silent war fought not with bullets, but with silicon wafers thinner than a single human hair. Artificial intelligence runs on specialized chips called GPUs. These processors handle the trillions of calculations needed to train models like ChatGPT, Gemini, and Claude. One company dominates this market. Nvidia, founded in 1993 by Jensen Huang, controls roughly 90% of the global AI training chip business today. But Nvidia does not manufacture its own chips. That impossible engineering feat happens on a small island roughly 100 miles off the coast of mainland China. Taiwan's semiconductor manufacturing company, known as TSMC, produces over 90% of the world's most advanced chips inside fabrication plants worth $20 billion each. These chips are made using machines built by a single Dutch company called ASML. Each EUV lithography machine costs around $300 million to purchase. The supply chain stretches across 3 continents. American designs, Dutch machines, Taiwanese factories, Japanese chemicals, Korean memory. Everyone needs everyone, until they don't. For decades this arrangement worked smoothly. Globalization meant chips flowed freely across borders, enriching every nation involved, accelerating innovation, and powering the digital revolution we all enjoy. Then artificial intelligence changed everything. Suddenly these chips weren't just powering phones and laptops, they were training the brains of future super-intelligent machines. Whoever controls advanced chips controls AI. Whoever controls AI may control the next century of economic power, military dominance, and scientific. In October 2022, Washington dropped a bombshell. The Biden administration announced sweeping export controls preventing the sale of advanced AI chips to China without a special license. The restrictions were unprecedented. Any chip exceeding specific performance thresholds was banned outright. Nvidia's flagship H100 processor, the gold standard for AI training, was completely off limits. Nvidia engineers quickly designed downgraded versions called the H800 and A800 specifically for the Chinese market, carefully staying just below the new regulatory performance ceiling. But Washington wasn't fooled. 1 year later the loophole closed. The H800 and A800 were also banned, blocking an estimated $30 billion in projected sales overnight. China responded by stockpiling aggressively. Chinese tech giants Baidu, Alibaba, ByteDance, and Tencent placed $5 billion in orders for chips before the new restrictions took effect. Meanwhile, a shadow market emerged. Singapore, Malaysia, and the United Arab Emirates suddenly became major Nvidia customers, receiving far more chips than their domestic economies actually needed. Reuters investigators discovered Chinese buyers paying premiums of $50,000 per chip on the gray market, routing purchases through shell companies in third countries. Some smugglers got creative. Authorities intercepted advanced chips hidden inside live lobster shipments, fake silicone pregnancy bellies, and even servers disguised as ordinary gaming computers crossing borders. China did not just resort to smuggling. Beijing poured $150 billion into building a domestic chip industry capable of replacing foreign suppliers entirely. Their national champion is SMIC, the Semiconductor Manufacturing International Corporation. In 2023, SMIC shocked the world by producing a 7-nanometer chip inside Huawei's Mate 60 phone. Analysts had said this was impossible without restricted ASML equipment. Somehow SMIC pulled it off, although at higher cost, lower yield, and questionable long-term scalability. Huawei itself became the centerpiece of this rivalry. Once the world's largest telecom equipment maker, US sanctions nearly killed the company before AI suddenly gave it new life. Huawei's Ascend chips now power Chinese data centers. They lag Nvidia by roughly 1 generation, but they exist, they work, and they ship in growing volume every quarter. Washington tightened the screws again in 2024. New rules expanded the export ban list, capped chip sales to dozens of countries, and targeted Chinese semiconductor toolmakers directly. Behind the scenes, espionage intensified dramatically. The FBI opened investigations into alleged chip technology theft. Multiple engineers were arrested attempting to smuggle proprietary designs out of the United States. In Taiwan, things grew dangerously tense. Chinese military aircraft crossed median lines almost daily. Beijing leaders openly discussed reunification. The world watched the Silicon Shield with growing unease. If China invaded Taiwan, TSMC fabs would either be destroyed, captured, or remotely disabled. Either outcome would freeze the entire global economy within weeks of any conflict beginning. Washington pushed TSMC to build redundancy. $40 billion in subsidies under the CHIPS Act lured a massive new TSMC fabrication plant onto Arizona desert ground. But the Arizona fab faced delays, massive cost overruns, and a skilled labor shortage. The first chips finally emerged in late 2024, years behind original schedule and significantly over budget. Inside Nvidia, Jensen Huang walked a diplomatic tightrope. He lobbied Washington for fewer restrictions while reassuring Beijing his company remained deeply committed to serving Chinese customers long-term. Then came DeepSeek. In January 2025, a tiny Chinese startup released an AI model rivaling GPT-4, claiming it was trained for under $6 million on supposedly inferior chips. Here's what changed everything. DeepSeek's revelation triggered the single largest one-day stock market loss in history. Nvidia lost $600 billion in market value in just one day. The narrative collapsed overnight. Maybe China didn't need cutting-edge chips after all. Maybe clever algorithms and efficient training could match brute force computational power. Investors panicked. Wall Street woke up to a terrifying possibility. Trillions of dollars in AI infrastructure spending might be wildly overestimated. The entire investment thesis around AI was suddenly questioned. But the truth was more complex. DeepSeek actually used roughly 50,000 Nvidia chips, including smuggled or pre-ban H100 units, far more than the company's founders publicly disclosed. Yet the export controls had failed in their primary mission. China had built competitive AI without freely available top-tier chips. Years of restrictions hadn't slowed Chinese progress meaningfully. And then a new bombshell hit. Trump's second administration announced potential restrictions on every country, threatening even allies like South Korea, Japan, and the European Union with new export caps. Markets convulsed wildly. Nvidia shares whipsawed daily. Geopolitical risk premiums soared. Every major tech company reassessed AI investment plans amid sudden, deep uncertainty about supply, demand, and regulation. China retaliated immediately. Beijing announced antitrust investigations into Nvidia, accelerated subsidies for domestic chipmakers, and threatened export restrictions on the rare earth minerals essential for advanced semiconductor manufacturing globally. The semiconductor war had reached its absolute peak. Two superpowers, locked in technological combat, with every other nation forced to pick sides, or risk losing access entirely to AI's future. So how did we actually get here? The mechanism is simple. Advanced chips became strategic infrastructure, just like oil in the 20th century or electricity transmission grids before that. Nations that control strategic infrastructure dictate global terms. Whoever leads AI development will shape economic outcomes, military balance, scientific breakthroughs, and information access for the coming decades. Export controls work imperfectly at best. They slow rivals down but rarely stop them completely. China demonstrated that constraints actually accelerated domestic innovation in unexpected, sometimes unwelcome ways for Washington. Globalization in semiconductors is unraveling. Each major power now pursues self-sufficiency, building parallel supply chains that are less efficient, more redundant, and ultimately more politically resilient long-term. Consumers will pay for this fragmentation. Duplicate fabs, redundant tooling, and lost specialization mean chips cost more, electronics get pricier overall, and AI capabilities advance somewhat slower across the entire globe. Taiwan remains the central pressure point. Until Arizona, Japan, and Germany fabs scale meaningfully, the world's most important technology depends entirely on the stability of one contested island in the Pacific. The lesson echoes across all of history. Whoever masters the fundamental tool of an era, be it steam, electricity, computing, or now artificial intelligence, ends up shaping the century that follows. This isn't just a trade dispute between two nations. It is the defining technological struggle of our generation, and every smartphone, every server, and every self-driving car eventually depends on the outcome. Subscribe for more deep dives into the hidden battles shaping our future. Comment below, who do you think wins the Silicon War?